Hey, hello and welcome to the show. It's me, John Park, and I just totally smudged my glasses. I thought I was being smart. Gosh, that's terrible. Off to an amazing start. Aha! Cleaning cloth. Let's fix this. Thanks for joining me, by the way, and putting up with all this. We've got a show that starts off exciting and gets excitinger. This is how it. Ooh, that's so much better. Wow, yes, that's much better than a t-shirt. So what's going on here? Hey, we've got a show here for you. And what are we going to do? Well, I've got a coupon code for you so you can buy some stuff from Adafruit at a discount. I've got a recap of a product pick of the week. I have a CircuitPython Parsec that's a pretty snazzy hack. What else? I have a Learn Guide recap. I have a new project kick off that I'll show you. And I think there might even be something else, but we'll pretend that was it. What's up? Hey, apparently my audio cut out for a moment. That's probably because I'm bouncing around a bit. Please tell me I didn't murder another microphone. It's taped right there, secured. Hopefully that stays good. Just change the batteries to on the receiver. The transmitter looks good. But thanks for the note over in the chat. Let me know if the audio has another problem. Yeah? Good. Okay, well, let's get started. So first of all, coupon code. No, actually, first of all, who am I talking to? Look, this is the Discord right here. If you want to chat with us here while we're doing shows, this is not a bad place to do it. I am keeping an eye on the YouTube chat as well. Hey, Dave Odessa for joining over there. But this is our Discord chat that's active all the time, regardless of the platform. So if you're on Twitch or Facebook or somewhere like that and you're wondering where the chat is, that's it right there, adafru.it/Discord. Look for the live broadcast chat channel, boop, right there. And you will find people hanging out, such as, who's here? Liz, welcome back, Liz. All the things, Andy Calloway, some nice, hello. C. Grover, hey. Starman, howdy. Todd Bott, welcome. And anyone else who joins by, Fuzzy Bear is typing right now. So yeah, that's the Discord chat. Go there if you want to chat with us. And there's lots of other channels that are active all the time, lots of neat things going on. Such as Project Help, different subjects that you can check out, pet photos, and on and on. Next up, coupon code. Hey, that right there, Doom Keyb. We're doing a Doom keyboard project today. So that is your coupon code, Doom Keyb. It almost looks like a weird palindrome or something like that. Doom Keyb Bedek Moob, maybe backwards. So that right there is going to get you 10% off in the store. So head over to Adafruit.com. In fact, let me hide the background here. If you go to that place right there, Adafruit.com, let me go to the main page right there, and check out new products. We have some cool new stuff. You can click on View All New Products. Go check some things out. I actually want to pick up some of these. Half-height, I didn't really know this existed. Half-height MX compatible key switches, so you don't have to go over to chalk, which means you got to get completely different keycaps. This is actually MX keycap compatible, Cherry MX keycap compatible, but they are half-height. Shorter is nice in this case. So that's some stuff, and you can get 10% off of that or any of the other neat things. Look, there's still 39 Raspberry Pi Pico 2s in stock. We've been, I think, putting in little batches of them. I think 100 went in for the show last night, and then another 20 went in after that. That's when I scored a couple. Raspberry Pi Pico 2, the RP2350. And I believe, I was talking last time about some restrictions. I don't think we have restrictions on Raspberry Pi products with the coupon code anymore, I recently learned. So that should work for pretty much everything other than the gift certificate subscriptions and software. But head on over to Adafruit, check out some of these product categories, and then use that right there, Doom Keyb. Doom Keyb. That'll get you 10% off in the store today until about midnight. Just go through the regular checkout process, and at the end there's a coupon code slot where you can fill that in. Also, relatedly, if you want to get some free stuff, just go to adafruit.com/free to see what some of the enticements are at different spending thresholds. These happen automatically in your cart. If you spend $99 or more, you will see a PCB coaster appear for the price of $0. If you spend $149 or more, the PCB coaster will be there for free, as well as a KB2040. If you spend $199 or more, you'll get free continental US ground shipping with UPS. And if you spend $299 or more, you'll get a Circuit Playground Express for free, as well as the free ground shipping in the continental United States, as well as the KB2040, as well as the coaster. All of that just based on spending a bunch. And we appreciate it. And you can still apply that to save a little on top of your free stuff. So check it out over at adafruit.com/free if you're ever wondering what is the free stuff right now. Starman over in Discord points out limit 2 on the Pico 2350s, RPi Picos. That's right, 2 is the most you can get. Oh no, and so discount code reports the coupon has expired. Let me fix that right now. Hold on one second. Let's see if I'm still... okay, it's going to take me a second. I'll fix it right now. Oh, and it's asking for two-factor authentication because we're very safe and secure, so hold on. And I'm going to authenticate. App. Oh. And why is that not working? Oh, let me refresh this. I think my authenticator didn't refresh. There we go. Come on, you can do it. We'll do it live. Yeah, thanks for your patience with me. Where is it? There we go. And I'm in. Okay, let me go look at my coupon. What did I do wrong? And let's see. What's today? The 5th. I made it for the 3rd. Todd just tried to trick me. Said I was sharing my screen during behind the scenes coupon code fixing. You think? All right. There, that should do it. So yeah, I don't know how quickly that propagates into the system. I think it's pretty instantaneous. So thank you for the note. That was my mistake. I entered the wrong date for the coupon code. So Fuzzy Bear, if you want to check that. You're saying you're seeing it in the reflection in the screen behind me. My gosh, the forensics going on. Okay, so try that once again. Doom Keeb, same as before, but now with hopefully a properly executed expiry date. I made it expire 2 days ago by accident. Oh, Fuzzy Bear's typing. Let's see. Here, I'll bring back up the Discord. Gina makes me laugh. It's fixed and working. Thank you. All right, I love the real-time feedback. I appreciate that. Okay, so that actually is a decent segue. Hopefully everything's working for me to jump into a product pick of the week recap. So on Tuesdays, I have this show right here, JP's product pick of the week. I pick something from the store. We get to slash it in half price-wise and offer it to you. I do a little bit of a demo, and here is a little 1-minute recap of that, so check it out. It is the HX711 24-bit ADC for bridge and strain sensors. Not I2C, this is this SPI-like interface, and I'm sending power and ground to the VN and ground, and then I'm using 2 pins, I think it's D5 and D6 here, to go to the clock and data pins that are on the HX711 breakout. Then I've got my sensor wired up to the terminals, and there's 2 pins that are not used there, so I could plug in a second sensor if I needed to. Here I've got a 7/8 socket here weighing in at 55 grams roughly. I could swap that out for this big 1 1/8 socket, and this one is 209-ish grams there. The HX711 ADC for load cells and strain gauges. Yes, it is. Where am I? Where am I? Hey, there I am. Yes, thank you. By the way, Quinman pointed out that when I bring up that coupon code, I'm also bringing up another me. And how about another me? There's so many me's. And that was an accident on my part because well, not an accident, but I had a black background on there and I still wanted to be able to show up. And then I decided I wanted to show something else, so I broke it. So it's all behind the scenes silliness here today. Thank you for pointing it out. Okay, next up, CircuitPython Parsec. Okay, let me get this ready right here. For the CircuitPython Parsec today, I'd like to show you a Stemma QT port hack. This is useful for adding a couple of pins while you're prototyping something without having to solder any headers or wires to your board. So you can see here, I've got a KB2040, and I'm going to be actually using one of these in the Doom keyboard project. More about that later. And while I'm working on this, I didn't want to settle in on how I'm soldering stuff together, which pins are going to get wired to what, but I did want to be able to test essentially a latching button. And so what I've done is I've used one of these great little Stemma QT to test point connector breakout cables. So you can see we've got these little these little test point connectors that we can connect up to pins on the board. So if you take a look at my code here, you can see when I ground either of these two, the yellow or the blue, which are connected to the SCL and SDA on the Stemma QT port, I'm actually just using those like buttons. So this one right now, you can actually leave it connected there, so you can kind of latch it onto there, is showing that the SCL pin, which I'm calling pin 1, has been pressed because the value is false. It's a pull-down resistor. And here it is released, and I can grab that blue one there, same thing. I'm just touching the ground pins that are available. But you've also got a ground pin available right here on this black cable, so we can go and use that as well while we're testing things. And so the way this works is in the code, I'm simply bringing in time, board to get pin definitions, digital I/O because I'm doing pin stuff for button pressing and latching, and NeoPixel just so I have a little indicator. I'm setting up the NeoPixel, and then I've got these two pins. Pin 1, I'm saying digital I/O, digital in/out, board SCL. That's the serial clock on the I2C port right there, the STEMI-QT port. And then pin 2 is SDA, the data pin on that same port right there. Then I set those up as pull-down resistors, give them a little initial print that you'll see when I reset. So we can reset the board right there. You'll see when it starts, it gives us an indicator. It says, right now, both of those are not grounded, so the value is called true. Then in the main loop here, I check both of these pins. I say if pin 1 value, is not the same as the last pin value, which is what it was when it started, then we've experienced a change. This is sort of like a debouncing type of thing with state. And then I print the pin here, and then I fill the pixel there. So print pin 1 SCL released value, and then I print out the value. If it is released, then we say that it has been pressed. So show this in action. So pin 1, if there's a value on it and that has changed, that means we are connected. If there's a value off of it, then we're released. Have I gotten that backwards? I think I've gotten that backwards. If there's a value on it and it's changed, that's because we are releasing, and you'll see it says released. If there's not a value on it and it changed, since it has the pull-down resistor, then we have connected it. Same happens for pin 2, and then we have a little sort of debounce sleep there. The reason I'm using this is actually for some boot Pi stuff where I want to be able to plug this in and not have it show up as a USB drive, or I want it to only be a HID and not a MIDI. So any of those type of boot Pi operations are nice to be able to have a little reversible latch. And so while I'm testing this out, this is a really nice way to be able to get a couple of free pins for GPIO that you can connect up pretty nicely and securely without doing any soldering, without putting it into a breadboard. And so that is how you can do a STEMI-QT port hack inside of CircuitPython on boards with a STEMI-QT port. And that is your CircuitPython Parsec. Sorry, there's probably an echo on there. I left the mic open. Questions in the chat. McQueenman16 said, is it possible to make the SCL and SDA a software serial? I think so. Test it, or if anyone has done it for sure. I believe you can do software serial on those pins. I'm not sure if the pin out will reveal the answer to that or not, but this is the first step I would take. Is I'll do keyboard here in the store and run down to the primary guide. And yeah, already got the answer over in the chat. C. Grover says yes, they can be used as pseudo RX and TX. And so I think the pinout should show this. Let me go to large version of that. So down here at the bottom, you can see there's the pinout. We got ground, we got 3 volt, what is normally set up in CircuitPython as serial data, or S data, the I2C data and I2C clock. But those can also be GPIO pin 12 and 13. So I think I can call them by those names as well inside of CircuitPython. I would say GP12, GP13. Those would probably also be the Arduino names, if I'm not mistaken. And then you can see they are TX and RX. The blue one is TX, and the yellow one is RX. They can be SDA and SCL on a second port, SCA0, SCL0, in case you're using the ones over here as one. And they can be PWM pins on their own PWM bus. So yeah, there's a lot you can do using those, and it's a nice, convenient port. We got a lot of different cables for it, breakouts with DuPont connectors, both genders of those on one end, SDA or STEMI-QT to STEMI-QT, and then these nice little breakouts that I showed here, and alligator clips. So all those are really handy to have when you're doing stuff where you'd normally just take like a little piece of hookup wire and kind of rest it in the pins and hope everything stays connected. This is a nice little hack, I think. And actually, while I've got the pinout up here, since we'll be using this in the Doom keyboard project, one thing I want to point out that's unique to the KB2040 as far as Adafruit boards go. I don't know if we have any other boards that do this. We have breakouts for the raw voltage. That's going to be, whoops, this red pin here. That's what's generally going to be the 5-volt pin on USB, as well as the data plus and data minus for USB. So you can do high-speed USB 2.0 stuff with just soldering up those wires and ground. So with those 4 wires, you can avoid using the USB-C plug there if you're trying to keep things simple and cut down on cost as well as space. If you don't want to plug in a full-blown USB cable inside of there, we can actually solder to those points to hook it up to something like a hub. In the case we're going to, for the Doom keyboard, we're going to be using a hub that also has pins broken out for these things rather than just relying on USB connectors of any kind. So we might come back to look at that later, but that's why I've got the KB2040 on the mind. All right. Let's see, what else is happening here? We've got more people joining up over in the chat on YouTube, and I want to say hi to Gorkum, who says, hello, JP. Hello, Gorkum. And Beatagraf Avdalhagen is here and says, oh, hi. Hello. And then over in our chat, someone's got Doom's. I didn't know Doom had a keyboard. Very nice. It looks like big toggle switches. I dig it. Toddbot points out the MacroSynth plug uses one line for hardware serial receive. Let me see if we can show this. Yeah, let me show the Chrome capture for a second. So this is on Toddbot's GitHub, Toddbot/MacroPad synth plug. There's a link over in the Discord. And here he's doing the same sort of thing where he's got a Stemma QT cable there on the side of that MacroPad, but rather than plugging it into an I2C device, he's built a little breakout board that does, is it MIDI in? No, is it MIDI out and audio out? Now I can't remember. Yeah, MIDI in, audio out. So you can use it as a synthesizer and plug in TRS MIDI and go out with audio, the audio ports. So yeah, actually Todd was the one who came up with this idea and told me about it. I'm sure others may have as well, but he said, hey, Stemma QT port, the pins are not just I2C pins, so kind of a nice connector to have on there. I agree. All right, close that back there. And next up, what I wanted to do is a quick Learn Guide recap. So if we head over to adafruit.com, go to Learn, you can see right there in the middle is the USB-C power delivery monitor. Did I call it that? You know what? I had problems with, we've made some updates. I'm calling this the USB-C power deliverer. And it looks like the name didn't stick when I changed it last time. I'll look into that. Or maybe Lamore didn't like my name for it and switched it back. We'll see. But this is the project that I was showing last week. So Learn Guide is out and ready. I've got a little GIF animation of it there showing some different voltages and current readings. There's a little excerpt from this show, live stream, in there that shows it in use, which I think is helpful to just have a real video of it in use. And then on the build the power deliverer here, we've got a fritzing diagram there where I've got my Feather INA 219 current sensor and the Hub 238 USB dummy for selecting power delivery voltages from your compliant device. I can't remember how much I showed this, but this is the one I'm using. I really like this power delivery power packets from Anchor. ANKER. They're in the $85 range, and it's got, oh boy, it's like a, oh, I can't read that, but it's got a very beefy, I think 100 watt. Yeah, it's a 100 watt GAN technology, and it has 2 USB-C and 1 USB-A port on there. I think it can do power delivery of both of the USB-C, although for my needs in this project, I'm only using it off of one, and the other is just 5-volt powering the Feather. But a power supply like that, or if you have a laptop brick, a modern laptop brick with USB-C, there's a really decent chance that it can do power delivery. And I link to that on the first page, by the way. Under the Adafruit parts, I usually create a part there that's anything you have to get elsewhere. I happen to get it from Amazon, and I put that link there. Then I also show swirly grid and fasteners that you'll need for that, location of the fasteners, connections. I did switch this project at one point. It was a different, the other lower cost USB hub 238, HUSB 238 power delivery dummy that has solder jumpers rather than the dip switches, and we're not using the dip switches in this project, but that other one I had to solder to pins for I2C since we're changing the voltages over I2C. This one, which is a couple of bucks more, has an I2C Stemma QT connector on it, so it made it a solderless project, so I put that in there. If you don't want to do that, you can swap in the other one. You'll just be connecting directly soldering from Stemma rather I2C to I2C. There's my little 3D printed case and a link to the model files for that. And I put a STL, which is the triangulated polygons that you'd print on your 3D printer, in that, as well as the step file, which is really the sort of the source file for it. I made it in Rhino. I'm not putting a Rhino file in there with a Grasshopper script just because that's more complication than most people want. If you did want that, let me know. I'll post it. But a step is pretty useful for people who want to use some CAD software, open it up, and modify it without worrying about a baked-in baked-in triangulated polygon like an STL. So step is really just NURBS, planes, and trims. Shows that once it's printed, snapping all into place, and this was the updated one. I added little tabs on all sides to secure that swirly grid into there. And then in CircuitPython setup and usage, we've got the code bundle that you can download right here, and that also comes with all of the libraries you'll need for I believe CircuitPython 8 and 9, so you can grab that, grab the code, throw it on there, and it'll work. And then I've got an explanation here of how the code works, and then a little usage section here to show you how to use it. By the way, one thing I had done, so you can see you've got a lot of options because we have in fact, let me get it right now. You've got a lot of options because we have a screw terminal for the power output. So you could attach any kind of DC stuff, DC plugs and ports that you want there. I put a female 5.5 by 2.1 on there, pretty typical DC power cable. One thing I realized is sometimes you may have female side that you need to plug in, and I didn't really have an adapter for that. And then I realized this splitter is an adapter. If you get one of these little 2-port from female to male, you could plug in one male side of that, and now you've got female and male. Don't do this, but you've got those available for whatever you're plugging in. So this could go directly into something, or something with its own cable could go in here. So there's nothing to stop you from doing that. I don't think it'll burst into flames or anything like that. So that just occurred to me. I haven't even tested that. That just occurred to me this morning when I was cleaning up the desk and I moved this stuff that, hey, wait a second, that serves as a, there's no active circuitry in there or passive circuitry in there. It's just wires. So you should be able to give yourself any gender you need there without getting a fancy swapping cable, set of swapping cables. And this is the power of cleaning up the workbench, because you find things and notice them. I had those sitting off to the side and forgot to put them in the actual project. Okay, hey there BLD Designs, who just joined us over in the YouTube chat. Thanks for popping by. Hi, Uniscu7. Let's see, the discussion over in the Discord. Just wanted to see some talk of an ESP32 S4 reverse TFT. What? Is that a thing? I don't think we have one like that. S3, yeah. Okay, S4 was a typo. I was like, whoa! Starman's from the future. Yeah, S2 or S3 would work fine. Really, the only reason I'm using that feather is because we have the reverse TFT. Gives us 3 buttons to use on the side there, which is really convenient. I'm not using any of the Wi-Fi or anything like that on the ESP32, so it's still a great microcontroller for this kind of project, and we've got the convenience of that reverse TFT with buttons on it. If you look, here's a non-reverse TFT ESP32, and same nice screen, but since we have less space to put stuff, we've got no input buttons on that. Or is there one? I think maybe one of these buttons can be used in CircuitPython. I can't remember. So that's why the reverse. You'll see that here's a example of one of the reverse TFT feathers. We've got these nice buttons off on the side, which is really helpful, and the reset button is exposed there too, which is useful to have that available. Okay, so let's see. That is the recap of that project, and then I wanted to get into this Doom keyboard project. A quick reminder, Doom Keyb is your coupon code if you're just joining us and you're looking to buy some stuff in the Adafruit store and save yourself a little money. This will take 10% off the order. So since I'm starting the Doom keyboard project today, that is our coupon code, Doom Keyb. So what is the Doom Keyb? The idea here is a keyboard that you can plug into a computer over USB, and just like that, you'll have available to play a game of Doom right on that computer, whether it was already installed on that computer or not, and in a bind, even if you don't have a mouse, because we've got a little trackpad on here. So what's going to make this work? So we have these very minimal USB hubs, and this is my first project using one. So that right there is a 4-port USB hub. You can see it has a USB-C port that I'm plugged into right now, but it also has a solder pads only version of the same. So you can plug devices into this with bare wires. Right now you can see I'm using some little extension while I'm prototyping, some little extenders that we have that are USB-A to the 4 USB pins. So that's D-, D+, power and ground. And so this one can do 4 of those. So it's a 4-port hub, I don't think I have one I can pick up right now, but just like any 4-port hub, except those are usually the size of a deck of cards or so, and they expect you to plug in cables, which you actually start to run out of room, even in a big chunky-ish keyboard like this. There's not a ton of room in there for a whole bunch of cables. So the idea here is that I'm going to take the one cable with USB that's coming out of this keyboard right now is actually going to go into the hub. So it'll go soldering into this end. In fact, let me go to a down shooter here while I'm talking about some of this stuff. Let's go to it's oval. So I'm going to zoom in here so you can take a look at this thing. This thing's pretty neat. So it is, I think, a venerable USB hub chip, tried and true USB hub chip that you've probably got already in some of your commercial USB hubs. So here's the host side. So that's the same as this USB-C side here. So if I get rid of that and solder in wires directly from that cable that comes out of the keyboard, we're good to go. This can plug into a computer, and then it will serve up 4 ports. And I might be able to get away with 3 on this project. I have to think about it, or 2 rather. So we have a 2-port version and a 4-port version. I can't haven't figured out yet which one I'll need. But then you can see labeled here port 4, port 2, port 1, port 3. So for prototyping, I've soldered on some angled header pins. And I'm using the little USB-A breakout, which looks like this on one end, so I can plug stuff into it again until I commit to things and start cutting and cutting wires and stripping them to solder onto there directly. And so this will be, refocus here, hosting the hub from the computer, and then I have a thumb drive, happens to be a little baby one. What is this thing? 64 gigs. This costs a few dollars, very cheap. So I have, and it's even a name brand, I can't remember which one, SanDisk or someone. So I have a copy of Doom on there called GZDoom for Windows, gzdoom.exe, that runs off of a USB thumb drive. And I have one of the sort of primary Doom WAD files on there, essentially the level or the game. So that is a self-contained Doom that can be launched right off of there. And then on the other port, I'm going to have a... Did I lose it already? Where are you? Here it is. I'm going to have a KB2040. Now again, I won't need to be plugging in big honking cables because I'll be able to solder from D+, D-, 5 volt and ground to those 4 relative or equivalent pins on the port there. So with that soldered, again, we can keep this package pretty small. We might put them on top of each other. It depends on what space looks like inside the keyboard. And what this is going to be used for is I'm going to have a key on the keyboard. Either I'll rewire one or add a hole and add like a cool backlighted Doom key. When you press that key, it will tell this KB2040 to send a USB HID command to the computer it's plugged into. So over Windows, that'll essentially look like, hey, run the command terminal. So we'll do like Windows R, which brings up the run box. It will type in command and press enter. That will pop up a terminal, and then in that terminal we'll type in the command to run Doom off of the USB drive. So that's all this needs to do. So I want to start off with what that looks like in CircuitPython. And so let me bring up a window here. And yeah, we'll reload. Okay, so here is the code for this that I have so far. It has a path hard-coded in it right now, and I'm going to see about fixing that, maybe with a batch file that it'll be able to run to find out what drive letter we get for our USB drive. But so excuse that for now. But the rest of it is, I think, pretty much what it'll be right now. I'm just targeting Windows, but I may have an option for Linux and Mac OS if I get ambitious. But for now, I'm doing this on Windows. So this switch right here is something I'll be able to flip to other OSs if I get that working. But right now, I'm setting this one for Windows. I am setting up a button. Now, again, on this same concept that I showed in CircuitPython Parsec, it's really nice to be able to test stuff out without having to solder stuff on. And so I'm using the built-in boot button that's on the KB2040. So if you look at that one right there, its silk screen says boot. You can use this to put a new UF2 on it. You can hold that while you're powering it up if you want to get into that mode. But in CircuitPython, once this board has started, that's actually a usable button. That's a user button that's named button. So not even a pin number here, just board.button. So I can use that. So I haven't had to add anything, which is pretty great. And so my STEMMA QT thing would be if I want to latch a button on there or test an external thing, again, without soldering onto there. So that might be particularly useful for boot.py if I need to use that. But anyway, right now I've got just button in this code being looked for. When that gets pressed, we're going to launch our HID command. So then we set up keyboard and layout, which are USB HID keyboard stuff. And then I'm setting up, oh, that's not real. There's no pin 13 LED. I can turn that off. That's funny. I was setting a pin high, I guess, but I wasn't seeing anything because this just has has a NeoPixel on it. All right. You know what? I'll leave that alone. That won't break anything right now. Then I've created a function here called launch terminal. This actually could be named launch doom because what it does is, again, right now I'm ignoring if operating system is set to 0. If it's set to 1, we're going to do all this cool Windows stuff. So what it does if the operating system is set to Windows is keyboard send, which is essentially a press and release. So in keyboard, we have press, which is like holding a key, because sometimes you want to hold it for a certain amount of time or hold it and add something else to it, then release it. So we have press, we have release, and then we have send, which is a press release. So press and release can be useful if there's timing things that you need to deal with or order that things have to get pressed. But if they can essentially be sent simultaneously, like Windows key R, which is what brings up run, then we'll do keyboard send key code GUI. This you can also type in Windows here. That's the same thing. The GUI key is the Windows key. And then key code R. I am pausing here, I think, a quarter of a second to let that run window pop up because we're using this at sort of human interface speeds, so things take time to pop open. Once that's open, it gets focus automatically, and then we're using layout write. And layout write, instead of individual key sending and releasing, which is what keyboard does, layout allows you to send big strings of text and numbers in string form. So we're sending a CMD, and it gets sent and typed in essentially like someone typed it, so CMD. We can do the same thing with like keyboard send C, keyboard send M, keyboard send D, which would be boom, 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 and press all three. But this types it for you, which is convenient. And then I'm sending an enter key. So again, it's a press release of key code enter. That CMD in Windows launches the terminal. Once the terminal pops up, again, I'm sleeping a couple seconds to make sure that that pops open. I'm going to do layout write, and then this is how I'm launching. Like I said before, excuse this for being hard-coded for now. The D drive, which is what this thumb drive is showing up as on my test system, and then the path. In order to prevent issues with escape characters, I'm doing 2 backslashes, because Windows uses a backslash for a directory, but Python uses it as an escape character, so I have to put a pair of them to allow it through as text. So gzdoom is the directory on the drive where I have this gzdoom, and then gzdoom.exe. I pause a moment just to make sure that that gets typed in there before I hit enter. I don't think I probably need that one. I can look at getting rid of it. And then I press enter. And that should launch Doom. Now, that's a function that'll just sit there waiting to be called. When I power up the board, we just watch for keyboard events. If we get a key pressed, and I'm actually not even checking which key because I only have one right now, but if we had multiple buttons, we could hone in on which button, then it will run this function launch terminal. So to demo it while I'm developing, I can just set this operating system flag to 0 and resave. And then I'll just go down somewhere safe down here and press my boot button. And it should print, oh, am I not, hold on, let me reconnect to this board. What is your name? You are keyboard. Oh, it didn't connect. Let's see. KB. There we go. Okay, so if I press there, you can see it just prints Oh, and I'm not typing with it. I didn't need to be paranoid and put this comment in here. I'm just printing to the terminal right now. So I'm going to switch this back over to operating system 1. And this could potentially be a toggle switch of some kind on your keyboard, a little dial that you turn with a switch or something like that, multi-position switch. So for now, I'm just going to say it's going to be in Windows mode. So what I'll do is unplug this. I'm going to plug it back into my bundle of hub here. Let's see. Actually, you know what? I'm going to plug it just because I don't have the keyboard directly in here. I'll be taking up that spot. So let's let me get back to focus here. So let's talk about how this will be plugged in. For now, I'm going to go directly into the laptop with just the KB2040, and then into the keyboard in here, and this side to the laptop. So let me go back to the overhead on the other side there, and I will show all that instead of just telling it. So let's go to Benchcam here. Now the idea is this will make more sense when it is a, oh, that camera died, hold on. So it'll make more sense when this is a desktop computer, not a laptop, because the laptop has a keyboard built onto it. But again, this is my test system, and then I'll switch this up for a proper desktop computer. Okay, so let's bring all this over here. And let me wake this machine up. Okay, let me log into it. There we go. And in fact, I can show just the KB2040 first. So that'll be KB2040 plugged in. Right now, this is actually, you might have heard it ding. This is showing up as a USB drive. I told this Windows settings, what do they call, auto run settings, to not pop up the Finder or the file system explorer when it experiences a drive. But you won't be guaranteed that on other systems, so that's where I'll probably use the boot.py to turn off USB drive on this, and then I would use my little STEMMA QT cable thing plugged in if I wanted to do development on it and make that drive show up. But once this is deployed, I shouldn't need that drive. So that's one consideration there, is I just don't want it showing up. Now what you should see, here's the full show. So I'm gonna press, and I should probably put some bigger pauses in here. It's gonna go by kind of quick, but what you should see when I press the boot button is that it will bring up the little run window over here. I can zoom in a bit. There we go. It should bring up the run window, and then type in CMD, press enter, which will bring up a terminal. It'll wait 2 seconds, and then it'll type in the command to run. Oh, I forgot, I do need to plug this in because of the thumb drive, to run the Doom off of the thumb drive there. Okay, so let's go ahead and find the boot button. Here we go. 3, 2, 1. Didn't do anything. What did I do? Did I not save? Is it still in Mac mode? I thought I changed it. Hold on. I doomed it when I did a countdown. Nothing will doom your demo more than a countdown. Hold on. Let's come back here. So let's plug this back in here. Okay. Operating system set to Windows. All right. Hold on, let me set it back to Mac. Just test the boot button there. Yeah, I think it tried to print. There it is, Mac, Mac, Mac. Set that to Windows. Save. Okay. I don't dare test this because GUI button is something on the Mac, and I don't know what Command R is going to do inside of this software, so I could wreak havoc. So I'm gonna. I will be kind to the board and hold reset while I unplug it. It's the right way to unplug that. Could be I freaked it out before. Okay, so we're plugged in, we're running. Here we go. There we go. Oh, it's typing and launching and Doom! Yes. Oh, I didn't change the camera view. You didn't see any of that. Hold on. That's the worst demo ever. I was watching a feedback monitor over here, not the actual broadcast monitor. Okay. Now we're done with the warm-ups. We can start the real show. Here we go. So bench cam and main cam. I'm going to move this over. Can't see it. Sorry, Andy. Okay. Here we go. I'm going to close this just so there's no shenanigans. You know what? I'm going to close Sublime Text here in case that auto-loaded code. Okay, so we're plugged in. KB2040. We're also plugged in the hub, which has the D drive there, the little thumb drive. And I'm going to press boot. Here we go. Command. Launches the terminal. It types. Hits enter. Doom just loaded off of here. Doom is running off of there. And we can start a game. Like I said, right now it's just a little trackpad here because I don't have a mouse connected, which is less than ideal. So part of the question is, should I do some sort of mouse integration? Oh, that's not very bright on there. I can flip that down a bit. Can I adjust the... Oh no, I've got auto exposure on there, so that's just going to stay that way. So yeah, do I integrate a mouse into all of this? Who knows? So let's add this wrinkle to it of this other keyboard. So take this keyboard. Can it sit on here without pressing stuff? Yeah. Okay, so let's zoom out. Okay, so I'm going to escape out of here. And I'll close that. So this is actually what kind of will be happening, with the exception of I didn't add a third port on here for this hub. So that's in its own port. But I'll take my big chunky keyboard here and plug that into the tiny hub. What is this guy's name? CH334F. So I've got my keyboard plugged into this little hub. I've got my D drive plugged into this little hub. Eventually I'll also have my KB2040 plugged into this little hub, and then the hub is the only thing that'll go to the computer. So right now it's simulated. So this keyboard now is active. Pretend all this is shoved into here, and that this button is wired out as a key somewhere. And so a couple ideas on this. One is to take over a key, an existing key, and essentially cut its traces and wire it directly here. Or cut a hole somewhere to add a switch, maybe one of our custom keycaps, and I can put a little Doom logo in there. I could backlight it. I could use a Neo key over I2C. So we've got some options there. But pretend that's in there, and I press the boot button. Again, it launches the terminal. It launches the Doom command. Doom just started running off of the little thumb drive, and now this keyboard is active because it's plugged in. So it's not using that laptop keyboard now. So that's the idea there. Let me take some questions, just see if there's any thoughts or questions over in the chat about this. And then we'll take a look inside that keyboard to see how we're going to get that working. So let me see. In the chat here, let me scroll up. Oh, good. So Janiscu7 has some suggestions on dooms to look at. So I'll check out some of those dooms. Thank you. Lots of doom. Good, good, good. Also, I'll probably ask questions in one of the other channels, maybe just general help with projects about, or maybe there's one with Windows stuff about batch file things. If anyone knows, because essentially that drive is showing up as the D drive because there's only a C drive on that machine, but I want to see if there's a way to hunt by volume name. I can give it a unique volume name and then find the drive letter from that and inject that into the path there. So there's a bit of batch file, Windows, Magic, Python stuff there that I'm unsure of. So I'll ask a more coherent question about that in the future. All right, so let's take a look inside this keyboard to see how we're going to fit all this stuff. Let me go back over here and to here. So I briefly unscrewed it this morning just to make sure it actually unscrews. And we'll be able to get into it, which we can, but I didn't really take a look. So let's move that laptop out of the way there. Unplug these things. And let's get inside of here. So this is a pretty nice, I think it's, I have a keycap puller over here. Yes. I think these are Cherry MX Black keys on here. And 1 second, I'm going to bring up my Discord so I can keep an eye on the chat. Hey. Oh, my phone just crashed or something. There we go. Adafruit chat. Oh, Andy says maybe create a share to that volume name and run it from that share. Oh, interesting. Okay, so these, yeah, I think these are Cherry MX Black keys on here, which is not everyone's favorite, but I kind of like them actually. Yeah, so we've got some actual Cherry MX Black keys, which they aren't kidding. They make them fully black, stem and shell. You'll notice they're not shine through, so this is not made for LEDs on these ones. So I may add my own key somewhere to do the one. This has the little built-in trackpad, and it's actually not bad. It's good for in a bind to just plug it into a system and have a way to get a machine up and running. A couple mouse buttons there. So let's take this apart. I lost one screw. Amazing. I was really thinking I was clever leaving them just like this in the back, and then I bumped it and one went flying somewhere on the floor. This is not the most delicate way to unscrew these, but there we go. Yeah, mostly I just wanted to double check that there wasn't a hidden screw under the label, which is often the case. One more. One more. There we go. Yeah, that's what happens. These guys pop out. So, in fact, let's get those out with a big stack of magnets. It's a nice way to retrieve screws is some cylindrical magnets stacked on each other. One more. Okay, so what I saw earlier is that those are the only screws holding that keyboard, the case and the keyboard. Oh, I missed another one. So the keyboard is loose inside the case there, but there is a ribbon cable connector for the trackpad that's in the front here. So, oh good, I just ditched something, a spacer of some kind that I didn't see where it goes, so hopefully that's obvious, or there's a picture on the internet somewhere of it. Okay, so trackpad has a ribbon connector in a couple of spots. Let's see what's the safest place to disconnect. Okay, that's just a friction fit one. There's no latch on it that I can tell. So there's the little trackpad mechanism. It does screw out, but I don't think I have a need to. And so now I think we can take out. Oh, okay. So that's funny. I don't know why they needed to do this, but they've got space here, a weird little. I don't know if that's a ferrite core thing or what, but the trackpad, maybe this works with different, they have different modules that can go here. So the keyboard plugs into the ribbon cable. The ribbon cable is then sticky foam tape stuck to the back of the case, and then to that front part. So let's say that one doesn't look like it, no, does it? Let's get a, I don't think that wants to come out of there. I'm going to leave that one in there. I think I will peel up this sticky tape maybe, just to get this out here. Oh wait, this is fed through here. Okay, this is just like a strain relief thing. How about that? Huh. Will I regret this? See if I can zoom in closer. Yeah, okay, that's just a little funny little strain reliefy guy there. All right, so that's out. So here's our keyboard. Looks like they have a little controller board here. Not a diode matrix. And so let's take a look at our space. So when, zoom out again, when we are sitting in here, this is why I took all this apart, because I want to see. Okay, we don't have really a ton of space under, but we do have a bit. So, okay, so this area right here, I'm going to give you a reflection so you can see it. This area here, there's nothing in there. Nothing protrudes down from here, and this is all empty space right here. Okay, so that's pretty good. So if we take a look at what we want to fit in there, this over here is where the cable comes out. So somewhere over here, that cable will not need to plug into the USB-C. And this is kind of the point of this whole project, really, is that plugging in USB-C while you're inside of an existing case kind of stinks, because it usually means you have to like find some compromised position where you can do this kind of thing and then route stuff back around. So we're kind of doing away with all that. So that cable right there is just going to be direct to the hub, keyboard to hub. I might reuse this existing cable to go out to, sorry, I don't know if you can see that. So this is the cable that goes right now, keyboard out. So that's going to go to the hub, and then we'll go keyboard to the hub itself. And then this one here, we have some choices of some smaller female USB connector breakouts that I can just plug like tiny, like boop, and it'll be in. So I don't think I'll need these kind of adaptery pigtails. If we did, we probably can actually fit. I think the height works at there. Yeah, that's shorter than these standoffs. So we could fit that in there with the USB drive plugged into it, but I kind of don't want to. I kind of want to make it much smaller than that. And then again, the little KB2040 does not need USB-C plugged in over a USB-C port. It can just be the 4 wires. It can live anywhere. And then we'll have a connection to a key somewhere in the top here. Maybe an existing one like the pause break button gets swiped, or maybe I cut out a hole to put a new one. But I think if I don't want to unplug these right now because I'm still testing it, but I think if I just route things around a bit, that's all that's going to live in there. And that'll fit just fine. Yeah. That's actually snugly in there. Zoom out a bit. This will go back on. Oop. Like so. And we should have all of the Doom we need built right in. And I wonder what this was. I bet you went there. Yeah. Okay. All right, so that's the idea behind that. Let me know if you have any thoughts about that over in the chat. I'm going to run back over there now. Oh, wait, I left the chat sitting right here. McQuinmass, do I have a 3D printer? I do. Do you have some ideas on that? Let me know. And let me go dive into the chats a bit more. Ferrite core. Ferrite core? Tyth's a trackpad gamer. All right. Relative paths instead of an absolute path might be available, says Todd Bot. That's good to know. So, yeah, it should just start at the root. So ./gzdoom. Maybe. I have to dive into this stuff. Need some finagling. Yeah. A little finagling is all I think we're going to need. But excited about this. Kind of the first time I'm doing an integrated hub project. I think that could be really useful for people who do cyber decks and other computers where when you look inside them, there's like a whole bunch of wound up USB cables plugged into a port that's trying to fit into a smaller space. So this will get USB hub stuff down real small. Thumb drive is tiny, gives us plenty of space. Oh, McQuinman says you can make a custom keyboard top. Yeah, it's possible too, or a little add-on thing, a little add-on button to it. We'll see. Thank you for the suggestion. All right, I think that's going to do it. So that's what I've got. Don't forget, Doomkeeb. That is your keyboard. That is your keyboard shortcut. That is your coupon code for today. If you want to go and save 10% in the store. Grab that, Doomkeeb. That'll work until about midnight East Coast time this very night, the 5th. Today's not the 3rd, today's the 5th. Get you 10% off in the store. What else? I think we got a deep dive with Scott on Friday. We have a whole bunch of shows coming up next week, including, I believe, check for Desk of Lady Ada over the weekend. We'll be back on Tuesday with a product pick, Wednesday with 3D Hangouts. I'll be hosting Show and Tell, guest hosting Show and Tell, so come on by, show and tell your stuff. I'd love to see it. Ask an Engineer after that, and then I'll be back with another workshop. All right, thank you everyone so much for stopping by. It was fun hanging out with you and showing you what we're up to here. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.